know that since this was the first question or the second question, it's not supposed to be that difficult a logic. So don't spend too much time in thinking about the logic for such questions for the first or second question. Try to get a simpler solution. Okay, and sometimes even the easiest solution will actually get you right. So if you had a brute force solution for this, just try it out. Okay, don't worry too much about it, because for all of these questions, the first two questions specifically, they are not really checking so much about your optimal logic. They're just checking whether you can get the output or not. Okay, and just to give you an example of that, let's look at the next question and you'll understand what I'm talking about. Okay, so the next question is called exchanging digits. Okay, and we'll spend a little more time on this. So we are given two digits. Okay, so we have over here compute largest number by interchanging the digits updated. So what does this mean? There is given two numbers A and B. Find the smallest number greater than B by interchanging the digits of A, and if it's not possible, print -1. Okay, so between A and B we have these numbers, so that is B can be like so big. Okay, and how many digits are there for B? There is like 1 2 3 4 5 6 7 8. So there are about again, let me just count them. There are about 8 digits that can be there in B. Okay, we are given two input formats A and B. Let's look at the input test cases so that we'll understand it. Okay, so before I move on, actually I think there is some questions on chat. What I'll do is I'll for all the questions that are on chat, please note them down. Because since it's a marathon, I'm trying to finish all of the 4 questions. Note down your questions. At the end of the webinar, I'll cover all of the questions that you have. Okay, so I want to cover all of the 4 questions first so that everybody gets a hang of the logic, and once everybody has a hang of the logic, then let's try to get into the test cases again. Okay, anyways, so look, let's focus on this question. The question name is exchange digits, and what the exchange digit says is we are given two numbers A and B. We are supposed to exchange certain digits in A such that it gives the smallest number greater than B. For example, we have 459 here. If we just exchange 45, this in 45, that is 4 and 5, we exchange it, it becomes 549. Now we could have also exchanged 9 and 4, but it wouldn't be the smallest number greater than B. Okay, so let's just write down some of the test cases and see what's actually happening. Okay, so one second. So what we're going to do is try to write down all of the test cases and see what's actually happening over here. Okay, so the question given says, let's say we had over here the first test case, that was 459 and 500. This is A, this is B. We have to change some of the digits in A, only one, that is you have to interchange one of the digits in A such that it becomes the smallest number greater than B. Now if we change 5 and 4, it becomes 549. We could have made it let's say 954 if we had exchanged it, but 549, while still being greater than B, is the smaller number. 954 is also greater than B, but the smallest number greater than B is 549. Alright, let's look at another test case so that we'll understand. So the other test case that we have is 645757, that's A, 45757, and for B we have 457765. 457, sorry, one second, 457765. One second. Okay, what I'll do is, okay, so we'll look at another test case over here, and the test case is 64564 5757 5757, and the second test case is 457765 457765, and in this we have supposed to somehow change the values of A, that is we are supposed to change some of the values of A such that it becomes the smallest number greater than B. Okay, so it becomes the smallest number greater than B. Okay, so over here what is the value that we can change? Well, what we could change is we can just change 4 and 6. Okay, so this number, if we make it 465757, you can't get a smaller number that is greater than B. Okay, so that is the output we get over here. I'm just trying to think why the question is given separately. So the answer is something else in the question. To changing the digits of A, if not possible, print -1. All right. Okay. Okay, so we can interchange more than one digits of A. So that is, so as per the output, this is not the answer. The answer is in fact 465577. That is what the answer is in this case. Okay, let's look at another test case. So then we'll figure out the test case here is 5964 and it is 9984. All right. So in this case, no matter what arrangements you make in A, no matter how you change A, right, B, it will still never be greater than B. Okay, so no matter how you change A, it's never going to be greater than B. So in this case, we just print -1. All right, so I hope you understood all of the test cases. Okay, we have to just change the digits in A. We have to rearrange the digits in A such that they become greater than B. Okay, we have to interchange the digits of A, and you can actually interchange more than one as per the test case. So you change the interchange the digits of A, and after interchanging the digits of A, you have to find out the greatest number, the smallest number that is greater than B. Okay, wow, seems like a difficult question, seems like not like a difficult question, but it does seem like there's a lot of work involved. Okay, now just realize this is the first or the second question asked. Okay, so again, the thing you should realize is if it's the first or the second question asked, it's not going to be too difficult a question. Okay, that is, they're not trying to for you to figure out some very extreme way, some very optimal way, some optimal approach. They are not asking you to do that. Okay, because it's one of the first or second question. If it is the first or second question, they want you to just be able to get the answer. Okay, and so the way we are going to do that is to just get the answer. Okay, that is to just find out the answer. Okay, the easiest way to do it is, let's say if we take the number 549, right? So if we do take the number that was given to us, which was so what was the test case that was given to us over there? It was 459 and 500, right? And we have to interchange the digits here. The easiest thing you can do is actually generate all of the permutations and combinations of this and see which one is the least number greater than 500, right? If we generate all of the permutations, it becomes 459, 549, 945, 954, right? There's also a 495 over here, 495, right? So overall, 3 factorial, which is nothing but 6 arrangements: 459, 495, 549, 945, 954. If you generate all of them and if you sort them, then you can start from the beginning and check which is the first number that is greater than our given number, right? So if I take if I take all of these numbers, I sort them. So this is the sorting order: 459, 495, not greater than 500. 549 is the greater number than 500. All of the other numbers are going to be greater than 549. So 549 is the least number that is greater than 500. Okay, so this is the most straightforward way to do it. Okay, the easiest way to do it is generate all of the permutations that you can of the given number. How many permutations will be there? If the length is n, it is going to be n factorial, right? So we are going to have n factorial permutations of a given number. And if we are going to have n factorial permutations, we just sort all of the permutations and check which is the first permutation that is going to be greater than the given number. I think I have missed out one number over here, which is 594, right? Okay, but still, what I'm trying to say here is, if we generate all of the permutations that are greater than if we generate all of the permutations of A, then we just have to find the first number that is greater than the given number, and that number is going to be our given the desired number. So we just have to generate all of the permutations. Okay, now again, let's just hold back. If we generate permutations, won't it be just too many combinations? This is the part where you go and check the question again and see what are the constraints of the question. So the question constraints are this, and this is what we discussed earlier. There are about 8 digits maximum over here, right? So at max you can have 8 digits. If you can have 8 digits, then at max you're going to have 8 factorial values. Okay, when you say 8 factorial values, that is something like let's say around 50,000 or something. These are rough approximations you should know. Like 6 factorial is 720, 7 factorial is probably some 5,000, and 8 factorial is something like around 50,000 or 60,000 or so, right? So you will have that many combinations. All you need to do is figure out what are the combinations. Once you sort them, get all of the combinations that don't start with 0. That's the first thing you should check, and get those combinations that are going to be greater than the given number, right? Now this is not the most optimal approach, this is not the best approach, but this will get you the output. And your solution tomorrow, your approach tomorrow should be to just get the output, right? So if you are conflicted about what to do and what not to do, if you don't know what is even going to come out tomorrow, right? If you don't know how to even solve this problem, you know that at max you are going to get 8 digits. So 8 digits is at max, right? Just generate all of the permutations, sort them, and find out which is the first permutation that is greater than the given number. Now, how do you generate permutations? In Python, there's a very simple way. I'm sure that in other codes also there's that's other languages also there's a simple way. But just Google for this. This is a very solved problem. This is a very easily solved problem. How do you generate the permutations of a given string? This is a very simple approach that you can do. Is this the most efficient? Is this the best approach you can come up with? No, definitely there are much better approaches. This is not the best logic out there. And in fact, if they're checking very specifically for time complexity, this might take time. Except that again, for 8 digits, it's mostly going to go up to 40,000 or so, or maybe 50,000 at max. No matter how efficient you get, 50,000 is still a decent number, right? And not all of them are going to be 8 digits. So really 50,000 is an okay number to be going up to, because even if all of your things are going to be done in order n log n, for those of you who know sorting, but even then for 50,000 it's fine. It's only if you are trying to do some very big logic, at that point 50,000 becomes a bad number. But before that, it's completely fine. So some of you who do competitive programming and all, you might think, hey, what is this logic? Why are we generating all of the combinations? But your point tomorrow is to clear the exam, right? Is to get to the next round, is to get that interview opportunity. Try to do the brute force approach. At least 3, 4, 5 questions will get solved, right? Sorry, 5 test cases will get solved. You'll get certain points. Now, for those of you who want to get a more optimal approach, right? So if you want to go for a more optimal approach, then there is a different approach and we'll come to that. But my point first of all here is, don't attempt this one if the given constraints are given. Like the constraints are given that you're going to get 8 digits. Why do you even need to think about this optimal approach? If you're 8 digits and generating all of the combinations work, don't even worry about the optimal approach. So the first thing you're going to do is actually try the brute force approach, see if it works. If it works, great. If it doesn't work, then come to the optimal approach. But just try it out. 8 digits, it's not going to take too much time, right? So first you are going to try that out. And even before we come to the optimal approach, let's just summarize what was the approach that we were talking about, okay? What we're going to do is, we're going to generate all of the combination, okay? Ignore combinations that start with 0, because the length will change. Definitely none of these are going to be greater than b, okay? So that's the second thing that we're going to do. And then the third thing that we're going to do is, we ignore all, sort all the combinations, check the first number greater than b, okay? Some of the edge cases that you have to check over here are, what happens if the number of digits in a, that is the number of digits in a, are less than the number of digits in b. No matter how many times you arrange a or take any of the cases of a, it will always be -1, because it's like saying, oh, I give you a number 999, okay, please arrange the digits such that it gets the smallest number greater than 1000, okay? No matter how many times you arrange it, you're never going to get the answer, right? So in that case, this is the first case you should check. The second case that you should check is, if the number of digits in a are greater than the number of digits in b. In this case, you don't have to make any changes, any interchangement, right? Actually, you do have to make a slight interchangement. So if you look at, let's say if you are given something like 997, right? And you're given over here, what you could say is 77, let's say. So which number will it be? just take all of the digits of A and sort them, right? You just have to find the least number over here that is greater than B. So let's say it's 997, just sort the numbers, you'll get 799. That is the least number that is greater than B. Okay, so these are the two test cases. This approach that I'm talking about is when number of digits of A is equal to number of digits of B. Okay, that is when you check this test case. For number of digits of A less than number of digits of B, what you're supposed to do is just print -1. It will never be possible. If number of digits of A greater than number of digits of B, sort all of the digits of A and make sure that this thing 0 doesn't come first. Okay, and then see if it's greater than B or not. That is the first number that is greater than B, you take that. But let's come back to this approach. If the case that the number of digits of A is equal to number of digits of B, first generate all of the possible combinations. Then ignore the combinations that start with 0, because if we start with 0, then we'll have a 1 digit less than B. That won't work out. Sort all of the combinations and check the first number that is greater than B. Trust me, if the given constraints are like the ones that are given, this won't cost you too much time. It's a simple approach. It's the first or second question. So it's a simple approach. It will just help you solve the problem. Okay, so that's the one. But the more optimal approach here would be something like this. Okay, so let's say I have the number over here. Let's just again take a number like this. So let's say it's 459 is the number we were given, and 500 is the number we're given, right? Or better yet, let's take another number. So we have over here 47632, all right, and a number over here. So this is A, and B is something like 4 7 what you would say, okay, 4 7 let's take a better number here so that we all are able to understand. So what we're going to do is we'll take 2. Okay, but no, 2 is already bigger, so we'll take, yeah, okay, let's take that as 8, and this number we're going to take that as 477. So we'll take 47712. Okay, so we have to find out by interchanging the digits of 47638 which is the number that will be greater than 47712. Okay, I'll just write it again because I think it's just got a little dirty. 47638. So we have over here A 47638, and the second number that we had chosen was 47712, right? B 47712. All right, so how do we go about doing this? Well, the first thing that you should do is you should notice that up till 4 and 7 the numbers are same. So start from your most significant digit and go till that point where your numbers are same. Okay, because that is not where you're going to just go, because we just have to make A greater than B. We don't have to make A explicitly greater than B. We have to just make it greater than B. Okay, so we go from 4 to 7. We came to 7. It's at 6 and 7 that we are going to get a problem, right? So from the right side of 6, we try to find out that number which, if exchanged with 6, will give us a number that is greater than 7. Okay, here we just have to pick 8 and 6. If we just change it, we'll get the answer, right? But that might not always be the case. Okay, sometimes we can at max just make it equal. Okay, for example, let's say had it been 47637 and here we have 47712, right? We would have gone to 4 and 7 are equal. From 6 we try to take that number, we can get 7 only. Okay, so we exchange 7. So when we exchange, we got 7 here, we got 6 there. It became 47736, right? Our problem is still not solved because over here we made it 477. Then we came and we saw 3 is greater than 1. That is when we know that this number, it has become bigger than B. Okay, so it is the first number greater than B. So the optimal approach here would be to start from A, the most significant bits of A and the most significant bits of B, and keep going till the end of the strings, and till you reach the end of the string, take that first number that is differing between both of them. So let's say if take the first number that is differing between both of them and try to make it equal. If you can't make it equal, then try to make it greater. right? So first you're going to try to make it equal, because we want to get the greatest number that is less, we want the smallest number greater than the number. So first find the number that is going to make it equal. After you've made it equal, try to do that for the remaining parts. If you can't make it equal, try to get a number that is greater. Okay, now this approach might require a little bit of recursion, hence I was shying away from it. I said let's not get into it directly, because again, this is just one of the first two questions, and in the first two questions you're not supposed to apply recursion. So if you go directly into this approach, you can do an iterative approach also, and you can do a recursive approach. But my advice to all of those people who are just been practicing since the last week for CodeVita, try to generate all of the combinations, sort them. It will become just easier for you. Okay, if you are feeling adventurous and you want to try out, then you can try out the optimal approach. That is, you start from the most significant bit, go to that bit which differs, and then from the right side try to take a number that will make it equal. If it's not possible to make it equal, try to increase it. Okay, so that's the other approach that you can follow. Okay, so this was the question called exchange digits CodeVita 2019, and what we're going to do is we're going to try to put our solution online, so you can also see how we did it in Python, and I'm sure that in other languages also this will also exist. Okay.